Morning, everyone. Thank you for attending our session. I know everything's a bit spaced out all over these different hotels everywhere. So the focus of the session is going to be very much around Kubernetes and obviously with a big focus around AWS and EKS, as well as a mention around like Red Hat OpenShift on AWS as well, just another Kubernetes cluster ultimately. So before we get started, I'm Michael Cade. I'm a technologist at Veeam Software, focusing on our cloud-native strategy, reporting up into our CTO. And I'm joined with Deepika. Do you want to introduce yourself, Deepika?
Yeah, sure. So I've been with Kasten for about 4.5 years now. We actually got bought by Veeam in October 2020. So I'm with Kasten by Veeam now. So I'm one of the senior engineers here. And yeah, excited to chat with you guys.
Awesome, awesome. So just to get into it, couple of the things that we kind of want to get across. Now, we've got about 15 slides, and then the rest is demo. So the quicker I can get through the slides means that we can get to some cool demos to start off with. So first of all, we want to think about like that protecting Kubernetes and the applications within Kubernetes and some of the constructs that you may or may not have be familiar with, whether that database or data service lives within inside Kubernetes or external. We're going to touch on that. Maybe external being leveraging like RDS type services within AWS. We're going to get a bit of an overview of what Kasten K10 is and how it works and what we can do with it. And then some of the examples that we're seeing out there in the field where people are embracing that stateful workload within Kubernetes, specifically on AWS, and some of the examples and scenarios that we see there. So if we think about from a concern point of view when it comes to software delivery, like just to get a show of hands, how many people are from an operations side of the business? Okay, and then how many people are developers, software developers? Awesome. So generally speaking, we're normally talking to the operations people because that's where the responsibility of data and backup and data protection, data management normally lives. But really good to see a few developers in the room as well, because that's refreshing to hear. So generally speaking, so if we think about infrastructure operations teams, we're building tools, we're provisioning, we're managing all of that good stuff within our environments. And the application teams, the developers, are generally focused around building the applications, delivering the business value. And obviously from a last few years, we're probably seeing a bit of a merge, and that's probably why we're seeing a bit of a mix with the hands going up between operations and developers and having a bit more responsibility around data management within your business. Namely, probably because you understand your application and how the data service is leveraged within that. So to get in about Kasten, and this is really the key slide for me, if you all walk away and you remember Kasten K10 or Kasten by Veeam, the three things to walk away with is we're always going to start from that backup and recovery or backup and restore type use case to be able to protect those data services in, around, and out of the Kubernetes cluster and be able to restore that as fast as possible in the most efficient way. Then we think about the failure scenarios, the doom and gloom, the fire, flood, and blood, the disaster recovery. It still happens in Kubernetes. There's no silver bullet when it comes to Kubernetes. It's just another platform where we have to consider the actual bad scenarios that happen out there in the wild, right? So having the ability to move from one Kubernetes cluster to another, if something bad was to happen, is another key talk track that we have within our talk track at Kasten. And probably the most interesting for me and a lot of our customers is around this application mobility. Kubernetes can really live anywhere on any different platform. There's hundreds of different managed services out there that offer Kubernetes. Amazon even have their EKS, they have Rosa from a Red Hat OpenShift point of view. And being able to move that application between different regions or different clusters is a key part of why we use Kubernetes or why we're interested about using Kubernetes in our environment. So if we think about specifically for Amazon EKS, if we think about what do we want that to be or what do we want it to look like from a protection point of view, we want it to be native. By native, I mean that we want to be deployed within the EKS cluster, have an understanding of what that cluster is so we can be really efficient. So I definitely come from a virtualization background, like VMware background, and if we go back 15 years, there was a focus around protecting virtual machines with an agent. We had to put an agent onto our virtual machines, and that had a massive overhead to any infrastructure admin that was looking after that. It wasn't the most efficient way to do that. Along came Veeam, and we created an agentless way because we went into the vSphere API to be able to take a fast, efficient backup. K10 is very similar to that from a Kubernetes point of view. We hook into the Kubernetes API so that we're fast and efficient. We're not an image-based backup at all, so it gives us the ability to do all of that good stuff, but without that admin overhead of managing agents or having to really manage multiple resources or whatever we saw back in the day from a backup vendor point of view when they were putting their physical agents on top of the virtual machines. Multi-layered consistency. So if we think about a database, whether it sits in a physical machine, virtual, cloud, EC2 instance, or whether it's an RDS instance of a database, or whether it runs in a stateful set within Kubernetes, it's still a database. No database likes the figure of being the power cable being yanked out. We have to think about consistency. We have to think about truncation of logs. We have to think about what's that going to look like if we just take a point-in-time copy of that without actually talking to the database and having an understanding of how to stop transactions or at least pause those transactions so we can take a good, fast, clean copy of that data. Mobility, I mentioned around this, being able to send that database from one site to another or one Kubernetes cluster to another, that's a big ask from customers, given that Kubernetes being the cloud operating system per se, being able to move that workload, that data from A to B and back to A again, maybe if things get better or we're going through upgrade paths, but really having that integrated into the same user interface that we use to perform data protection acts. And then also DevOps, speed and scale, but what we mean by that is how do we encourage people to automate this process? Backup's a bit boring. I've worked here for 8 years. I know how boring backup is, but I know that we're an insurance policy, right? We're needed. You need to have it, and anyone in the room that's ever had a accidental deletion, an accidental drop, or making some sort of failure scenario knows that the restore is the most important part to that. But I don't necessarily always want to go into a UI. I want to be able to automate that. I want to be able to leverage automation. And one of the sessions that I did over in the Veeam booth yesterday was about how Kasten K10 can integrate into your GitOps pipeline. So how do we continually protect that data going from version 1 of our application to version 2 to version 3, etc. So being able to have that automation layer for potential developers that are mindful of data protection, while still having an operations side, a UI, to be able to set those backup schedules, those windows that you need from a UI perspective. So covering both parties, right? Exactly what we've got in the room is we had a show of hands from both parties. So if you think about Kasten K10 on AWS specifically, AWS have lots of different offerings. I mentioned about EKS because it's probably the most pronounced, but actually, if we think about EKS Anywhere, if we think about Rosa, another example, to us, they're just Kubernetes clusters. So being able to protect them in that way. Now, we are going to get into a little bit more of the specifics and the integration points that we have within there. But ultimately, for Kasten K10, we get deployed in that cluster, and we see it the same way to be able to provide that backup, that recovery, that disaster recovery mindset. The other key part to this slide as well is that not everyone is ready or wanting to deploy databases or data services within their Kubernetes cluster. I would say if we look at the Kubernetes release cycle over the last 2 years at least, every single release, so there's been 3, is generally around 3 a year. Each one of those 6 have had something to do with data and storage. We saw the CSI driver come in. Public clouds like AWS obviously adopted that into their GA release, and then so forth around stateful sets and everything else that's being adopted there. So there's a big push from the Kubernetes community and release team around data and storage and running that in there. However, there's still some people or some businesses that aren't happy or don't want to have that data service within their Kubernetes cluster. And what we're seeing there is that maybe they've migrated into, or they've moved their database service into an EC2 instance, or more commonly, they're moving it into an RDS instance and leveraging Postgres, MySQL options within Aurora in RDS. And from a K10 point of view, yes, we are deployed within the Kubernetes cluster, but we have to concentrate on the application layer. We have to think about the whole piece, not just the database, not just the PVC. We have to think about the whole construct and all the artifacts that make up that application. So we have the ability to dive into that RDS APIs to, again, be able to leverage that and protect the whole application from that perspective. So I'm going to spend a bit of time on some of these customer scenarios before we get into the demo. So specifically, we have a lot of customers that have multiple Kubernetes clusters, a bit of EKS on the East Coast, a bit on the West Coast. Maybe they have a central main site or requirement to store their data in a different location for the backups, I mean. And then their application is spanned over those two environments. So so I'm using EU here, but US is the same, right, in terms of locations. So what we want is the customer wanted the ability to enable cross-cluster backup and DR across these regions, and they had multiple data services. So they had NoSQL in MongoDB, a bit of Postgres, MySQL, as well as Amazon RDS being used. They also had applications that are deployed using EBS, but also using EFS. So different storage classes that are available to our EKS clusters or ROSA clusters. And they needed to be able to prevent from a ransomware attack or a malicious activity from inside the environment. Now, we don't see too much around cybersecurity threats specifically targeting Kubernetes. There was one back at the start of 2021 that was leveraging Kubernetes as a mining. They were getting access, malicious activity. They were then using it to mine Bitcoin of all things. But ultimately, this data is a database. It's a target for malicious activity, like a virtual machine, like any other system within your environment. So we need to enable ransomware protection, and I've got a demo on that, on how that looks from a Kasten K10 point of view, but specifically how it interacts with the Amazon S3, the object lock API that we have within S3. So if we think about that legacy data management problem that I just talked about, where we went from physical machines to virtual, and then we had agents on top of our virtual machines, that really wasn't the most efficient way. And if we think about that image-based backup solution there, that doesn't lend very well in the Kubernetes world either. Yeah, I can especially if your Kubernetes nodes are running as virtual machines, which they're EC2 instances, right? We can protect them using another Veeam tool. But actually, that doesn't give us much when it comes to recovery. As well, those nodes are generally ephemeral. I don't really care about them. I just need them to run my workload, and then they can disappear. We can scale up, we can scale down the actual physical node or the EKS nodes that we have. So we had to think about, this customer had to think about, how do we natively be able to protect the workloads that we have and have a little bit more visibility and granularity on the applications and everything that goes inside of the Kubernetes environment. And another key part, and I'll keep saying about this consistency, that database doesn't like just having the power cable yanked out, figuratively. The MongoDB, the Postgres, the Amazon, they're all databases. They live somewhere, whether it's in the Kubernetes cluster or not, then they need some care and attention to make sure that they're consistent, because when we come to recover, we need to make sure that they're in a good spot and they can come back with no issue. So Kasten K10 is deployed within EKS. There's a few options when it comes to deployment as well, and we're going to touch on that throughout the demonstrations as well. In particular, from an EKS point of view, we have the ability to integrate into various layers of the EKS like ecosystem or cluster by being able to leverage CSI, but equally pre-CSI, the in-tree provisioner from EBS, so the ability to take fast, efficient backups using GP2, et cetera, pre-CSI being rolled into EKS. So having that ability to do that, as well as leveraging IAM and security constructs that Deepika is going to also touch on. And then, again, those data services, how do we protect them in an application-consistent way? And I'll touch on that as well as we walk through, using an open source project that we maintain called Canister, but heavily used in Kasten K10 to be able to dive into those different application set or those data services to provide the consistency that I very much keep on talking about. And then being able to support the different storage classes I mentioned around CSI, but also the in-tree provisioners as well. The object lock API was the ransomware story. So how do we deploy Kasten K10? Kasten K10 is in the AWS marketplace, but we're also a Helm chart deployment, and Deepika is going to roll on that as we get into the demo. So let me walk through what the demos are going to look like, and then Deepika can actually show you some of this stuff. So building out the demo, what we're going to see is, let's take that customer scenario, but instead of it being Europe, let's bring it into the US. We're going to deploy an Amazon EKS cluster. Well, it's already deployed in US East 1, and then we're going to put an OpenShift, a ROSA cluster in US Central 1. And we're going to just show what that looks like in terms of protecting that workload or deploying that and then managing that from a data protection point of view. We're then going to deploy Kasten K10 in a secondary or a third location on the West Coast. So we're starting to build out this environment that I'm sure many of you have in your environments today. We're then going to manage that with our multi-cluster dashboard, because you don't want to be going into each individual Kasten deployment to manage individual sites. You can, but if you've got 10 different clusters, it becomes a bit of a pain and a burden for that. Then we're going to show some of that application consistency, and in particular, I'm going to choose a scenario where RDS is being used with the application living inside of our Kubernetes cluster and us protecting the RDS as well as the application inside, as well as a restore of that, and having the flexibility of that restore being able to push that to another RDS instance as a clone, but then equally being able to really migrate that data wherever it needs to be. So if it's not RDS, it can come back into a stateful set, or vice versa as well, but I'm not going to show that. Okay, so I think that's a good time, Deepika, if we jump into the demo. Do you want to talk about the Kasten K10 architecture?
You can figure that out, and I'll join at the demo.
So
you're in the zone.
So Kasten K10 is deployed within each individual EKS cluster or ROSA cluster. I'm just going to mention EKS cluster. If you think about Kasten K10 deployed in your Kubernetes cluster, the architecture of that and what that does is that enables us to become part of the Kubernetes API. So very CRD based, and what that allows us to do is be called by the likes of Argo CD. I mentioned the session that I did yesterday about how do we automate or take away that burden of managing and automating that process of backup in there. And then there's a few different areas and integrations that we have in there. So one is going to be the application framework that I mentioned, so using Canister to dive into the application and the data service that we have. It's going to be the infrastructure APIs, where I mentioned that we have specific integrations into AWS, so whether that be S3, whether that be EKS, whether it be CSI and the storage underpinning AWS. And then finally is the orchestrator APIs. Us being deployed within Kubernetes gives us a wealth of being able to be used with lots of different tools. From that perspective, we don't have our own RESTful API to confuse or to add complexity when it comes to security as well. Okay, Deepika.
All right, thanks, Michael. So I can talk more about how we deploy Kasten K10. So Michael showed you the slide where you can do it directly through the Amazon marketplace, but you can also do it through a Helm chart. So here's what I'm demoing here. You can add the Kasten repo. It's a Helm chart that will sit in its own namespace. So here I'm deploying it in the Kasten IO namespace. And the other thing to note here is I can deploy it with credentials directly when I'm deploying the Helm chart, so I don't need to go later and configure anything. So here I'm setting it up with an IAM role. So you can use IAM role, you can use your credentials, your key, your ID, all of that. So we integrate directly with AWS credentials. So that cluster is set up with all these credentials for whatever it might need to do with that infrastructure. So let me just continue talking while this plays out. So it's a simple Helm chart that you can deploy. So it doesn't take a lot of time. You can find it and deploy it in your namespace. And what it's going to do is it's going to create a certain number of pods in its own namespace. Again, like Michael said, not going the agent way. This is completely cloud native. So it's going to sit in your cluster. And we talk so much about cloud native, so our application has to be. So it is you can do all of this through Kubernetes APIs as well. So we don't necessarily need to go through the UI. You can do everything through the API. So that's how it integrates into your GitOps, into your CI/CD pipeline. Everything is cloud native. So all the APIs that K10 has are completely cloud native. You don't need to learn a new set of REST APIs for that. So let's just wait for this to get back on track, and you can see all the pods running. It integrates with the, as I said, with the Amazon infrastructure directly, and then I'll demo that, how that looks in the UI right after this. So yeah, we have all the pods running, didn't take long. I have not sped up this video in any way. Now, how do we integrate with AWS KMS? So here I actually have two set of clusters that I'm deploying at the same time, one on each side. And on one side, if you see, I'm creating a K10 cluster passphrase, and I'm giving it an AWS KMS key ID. So K10 by default enables encryption for all your data that gets backed up, but that's the default K10 encryption. Now, if you want to go the AWS KMS route, you can do that again during install. You just set up this secret, and then K10 will go in and identify that it's an AWS KMS secret, so it can talk to the AWS KMS for encryption and decryption. So just for showing the difference, we have two clusters here. So one I have created the secret with, and I'm deploying it with my AWS keys. And then on the other side, I did not set up any secret, and I'm still deploying K10 with my AWS keys. So again, this is the Helm chart deploy, so it's going to take a little bit to deploy. We necessarily take the secrets that you provided, the KMS information that you provided, and during startup, we talk to the service, and then we get all the encryption information we need to. So again, this is done in the background. You don't need to worry about it. You just give the credentials during install, and it should take care of the rest. So again, going the cloud native way, you can, once the K10 is installed, you can verify what kind of encryption it has enabled. So we have a passkey API that can be easily called with kubectl get passkeys. So that's what I'm demoing right here, where on one side you have a cluster that did not have AWS KMS enabled. So if you do kubectl get passkeys on that side, you're going to get the K10 default primary key, versus on the other side, when you do it, you'll see the K10 AWS primary key. So that way you can be sure that you're using the correct kind of encryption after you've deployed. You can also do this post-deploy, so you can deploy it by default and then eventually go in and create a new passkey which can do that as well. Now going back to the UI, and we deployed the cluster, what does the K10 UI look like? So this is what it looks like. I'm going to talk about the infrastructure profile a bit, but before that, let me just pause right here. Okay. So we deployed. Okay, that didn't work. Thanks. So we deployed K10 through Helm chart, and the UI is ready to be used. But you deployed the cluster. You want to know what your cluster looks like. You can come to the UI, to the support page, and you can see the Kubernetes type is AWS. You can see what version of K10 is using. It also went ahead and discovered what kind of storage classes you have available. So you have all the information in single pane of view. It will also tell you if there's a new version of K10 available, so you can go ahead and upgrade your version as well. Moving away from the information that we have here, if you remember, we gave it certain credentials when we did the Helm chart. So this is the default credentials that you logged in with when you created the Helm chart. So you can see we verified those credentials, and we created this default profile for you. So you can make sure that you have the correct credentials by looking at the UI. We also went ahead and validated that it is EFS and EBS enabled, so you can see all of that information in the UI as well. And this is the default profile. You can go ahead and change it if you want. You can add new credentials. You can do all of that post-processing later. But this is the infrastructure information that K10 is going to use to talk to the underlying AWS EKS cluster that you have. Okay, what's next? Yeah, okay, it's playing. So that's what the UI looks like on, install. It's a plain, EKS cluster. We've deployed K10. Now what to do? So going a little bit, what else we can do with AWS. I know Michael talked a little about, we can do backups, we can do snapshots, we can migrate applications from one cluster to the other. Now, how would you do that? So we can use an S3 target in the middle, so an object store essentially. So you can create a location target or a location profile. It's a simple UI form. Again, all of this is completely cloud native, so you don't need to be on the UI to do this. You can have profile YAMLs that you can have in your system that you can just plug in. You can create an Amazon S3 bucket profile right here. And so I've used S3, and I'm using the default IAM role that I installed with, but I can also give it credentials again. And then I can choose the bucket, and what K10 will do is it will go talk to the bucket, make sure it exists, and give you a valid or an invalid status. So it does all the processing in the background. So this process is done, the cluster is ready, the target is ready, everything is ready for us to set up. So yeah, that's a little bit about the deployment that we have here. Now we can talk about the K10 multi-cluster a little bit. I know Michael shared this slide a little bit. Let me go into the details. So now we have clusters deployed with K10, but one is sitting in US West 2, one is sitting in US East 1. We don't know what to do. We don't want to log into all of these clusters at the same time. You might have 10, 15, 20, I don't know, 50 clusters maybe. What do we, how can we manage all of them together? So for that, we have a centralized platform called the K10 multi-cluster dashboard. Basically, what it does is you can choose one of your clusters to be primary, and everything else can be secondary. So you can point to that one cluster, you can log into that one cluster, and you can get access to all your other clusters. Now we use Kubernetes native RBAC, so roles, bindings, everything that you're already familiar with. No extra information or no extra binding is needed to do this. We integrate directly with that, so you can use your AD account or whatever you might be using with your Kubernetes clusters, and you can use that directly with K10. So again, focusing on K10 being completely cloud native, not having to learn something completely new just for this. So what I'm going to demo after this is we have an EKS Anywhere cluster. We have two EKS clusters. One is in US West 1, one is in US East 2. They're completely disconnected from each other in terms of location. But through the multi-cluster dashboard, we can join them together and see everything from a single pane of glass. So actually, let me just go into the demo. That might be easier to show. So like I said, you can create one of the clusters as primary. So for that, we have a K10 multi-cluster tool. It's a tool binary that you can get online. So you can designate one of the clusters as primary with just a simple command. So K10 multi-cluster, set up primary, give it the context you want the primary to be, give it a name, all of that sort of thing. It does all the bootstrapping in the backend. So the cluster is ready to be a primary at this point. Again, going back to the cloud native wagon here, it creates its own namespace, a Kasten multi-cluster namespace, and you can do kubectl get clusters to view all your clusters. Again, cluster is again a custom resource that is Kubernetes native, so not necessarily a completely new thing to learn again. Now the cluster is designated as a primary. Now I'm going to add a secondary. Again, you can do it two ways. So the first way is again with the tool. So K10 multi-cluster, add a primary, and give it all the secondary. Give it all the information. So ingress endpoint, context, all that sort of thing. What this does is it goes talks to the cluster and gets all the information, sets it up. So now once that's set up, what does the UI look like? So for that, we can go to this page. So if you remember, the old UI had applications, policies, and other stuff. But once you've designated a cluster as a primary, you come to this UI. Basically, it's your single pane of view. It's your multi-cluster dashboard where you can see all your clusters. Your primary cluster is marked right there, so that's your primary. But you can also see all your secondaries. Now, I talked about RBAC. So when you add a cluster directly, you're not going to have access to it. You're going to have to go and configure it. So for that, the UI, you can just do a one-click setup. And when you click on that, it can give you customizable options. So do you want this user to have admin access? Do you want this user to have basic access? Do you want this user to have access to all clusters or only certain clusters with certain labels? So you can fill out this form, you can add users groups. Again, uses default K10 Kubernetes infrastructure. So you can add the same users that you have in your Kubernetes clusters. And then once I go back to the list page, you can see that now I have access to the cluster. I have all the information I need in this single pane. All the metrics are aggregated, so I can see everything in the same place. We added one through the K10 multi-cluster tool. Let's add another cluster, but this time let's add through the UI. So through the UI, there's a simple form. You can either add your kubectl, kubeconfig, or you can paste it in there. Again, same information. Get the ingress endpoint so that you can talk to the cluster directly, and the kubeconfig is so that you can talk to the API server. So we need both the information there, and then simply just fill out the form. Pretty straightforward, nothing crazy. What this does in the background is the primary cluster reaches out to the secondary, make sure everything's fine, and then it comes back saying that, okay, I have access to this cluster, everything works out fine. Now it's in my cluster set over here. So as you can see, we have multiple clusters, one US West 2, US East 1, all sorts of clusters all over the place can be viewed from this single pane of glass. You can switch between clusters easily. You can see what the local policies that are running, local information that might be running on there, information that can be specific to a cluster versus global is separated out. So let's talk about distributing a profile. Yeah, I know it's a lot of information. I'm going to try to pause. I'm sorry, I apologize. So if you remember at the beginning when I talked about how we deploy K10 and how we can set up an S3 target, so that was a local target, right? That was specific to that cluster. Now, if you're in a multi-cluster environment where you have multiple EKS clusters and you want to ensure that all your clusters have the same target, you can do that through this multi-cluster dashboard. So what you can do is you can set up a global profile, so global S3 target, and then you can distribute it to whichever cluster you want. So that way you can ensure that all your clusters have the same S3 target or the same location or whatever you might have. So this way you can have your primary cluster as kind of a template ground where you can have all your global policies, global targets, goals, whatever you might have, and then you can have your local targets as well in your individual clusters. So that way you can separate them out or combine them together, whatever suits your use case. So here what I'm doing is similar to the location profile that I created per cluster. It's the same form, it's just that it is identified as a global profile. So here I'm creating again an S3 target profile using the same IAM credentials that I had in this cluster, but this time it's global. So I'm creating, same way it gets validated in the backend, it will go talk to the S3 bucket, make sure it exists, make sure it can access it, all that sort of thing. Once it's ready, now you can distribute it. Distribute it is it's again, distribution is a cloud native, API custom resource. It just distributes objects to all the secondary clusters. So here the object is a profile. So again, a form where you create your distribution. I'm choosing a specific secondary. I can also choose by labels. So I can group some of my secondaries by label and then group some of my other secondaries by a different label, and I can choose to divide them that way. It takes a couple of minutes to sync, and you can see that the resources are synced by going to the cluster or whatever monitoring system you might have. So here I'm going to the secondary cluster. As you can see, I have my local profile that I had from before, and I also have a global profile. So this way you can ensure that all your clusters get the information that you might need. We can take this a step further. We have a target. Now let's set up a policy. Policy is basically a schedule in which you want to run your backups, or your imports, your exports, whatever. So here I'm creating a simple snapshot policy that's going to run daily, and I'm also going to export this information out to an S3 bucket. So in this scenario, what is happening is I'm going to snapshot everything which has the MySQL label. So they might exist in a cluster, they might not exist. At a future time, some new MySQL application might come into my cluster, but since I have this policy, it will automatically get covered by that. So this way you can set up your policies once, distribute them, and then not have to worry about, did I set up my policy on this new application that I set up? So I have a policy, I have the object target bucket with it, and now I've distributed them to my secondaries. So I can go to each and verify. Again, a local policy lives as is, and then I have an added global policy with it. So that way, you can set your global targets in one place, and then local admins or cluster admins can have their own policies for themselves. This is a primary. I did not distribute it to it, so it did not have the profile. So that way you can segregate, have labels on your policies, have labels on your clusters, so that you can group them based on whatever idea or whatever grouping that you have, and then you can distribute, or you can remove it from that cluster set. So that way you can group them logically with labels, or you can have a catch-all policy which gets distributed to all your clusters. You can do that as well. So yeah, that's it for the multi-cluster stuff.
Awesome, Deepika. So let's just put that into a bit of a summary in regards to, that gives us the ability to manage each individual Kasten K10 deployment within the cluster on its own. But then equally, if you've got multiple clusters, we can bring them all together, and you can start to create a policy-defined, a policy-based defined data protection strategy around, okay, gold, silver, bronze, tin maybe, and then you say, I want these label, and then label it with those types, and each one determines what sort of RPO, RTO that you want to achieve from that, as well as being able to provide role-based access control for the K10 multi-cluster tool, but individually as well. So if you've only got people that can only look after US East 1 because they're situated there, but they shouldn't have access to US West 1, then you can have granular permissions to make sure that that is the case. But then maybe there is someone that is in central IT that should have visibility and access to everything. We can then get into read-only rules and roles as well. So there's quite a lot of flexibility in terms of what you need to achieve there with that. So that then leads us on to, I think I said application consistency a good 10 times in the opening part. And there's lots of different ways of providing consistency. And generally, when you start to get into a database world, so I keep saying about database and flipping between database and data services, because when we get into Kubernetes, there's not just databases. We're thinking about login and metric systems as well. How important is that data? Prometheus data, login, metrics, etc., tracing. How do we protect that workload? But then you've also got message queues and other data services that also need to be protected, streaming data, etc. So we have to think about what that consistency needs to look like. How do we know that that data can be protected and brought back as fast as possible? Now, in the demo that I'm going to talk about is actually a use case where that application, maybe the web server, in fact, the web application lives within the Kubernetes cluster, takes advantage of all the scalability and the flexibility that I have inside of the EKS cluster, but my database is in RDS because it provides me the minimum management level there, so I don't have to look after the operating system, the patching, etc. of that. So lots of different. So the reason for this slide is really to touch on things like Elastic and other data services that aren't just your typical NoSQL and SQL databases, for example. So from a demo point of view, I think the one thing I speak to a lot of people on a daily basis around Kubernetes is a stateless platform. Everything that I've got in my Kubernetes cluster is stateless, but I would beg to differ that the application that you are running in your Kubernetes cluster is connected to some sort of data service somewhere. It might not live in Kubernetes, but it will be somewhere. There'll be a database that is serving authentication and usernames and passwords and access authentication and other reasons, catalogs, for example, will all be in a database somewhere. Some people have gone and put everything into Kubernetes, and some people keep it out, and RDS is a great example of that, but then also think about that migration from maybe on-premises into the public cloud. And maybe the database isn't the easiest to refactor into a stateful set within Kubernetes. So we've now got it as an EC2 instance, just running our SQL workload. So from this demo point of view, I'm going to try and do this without pausing it because I feel like I'm going to break the demo if I keep pausing it. Okay, so we have our K10 cluster, and you can see that I've defined some applications, some policies, and we've also got this usage and reports, which gives you a bit of visibility of what's going on. I have a policy that is protecting our stock demo app. Our stock demo app is a web front end that is then talking to a Postgres instance within RDS. You can see here that I have a front end pod, and then I have a replica set. This is our stateless workload, but it's connected via the configuration into a Postgres database. You can see here, here's the database within RDS. I got fancy with some zoom in as well. And the key part here is that I want or need to be able to protect not just the front end aspect, but I also want to be able to protect the back end database as well. So I'm going to manipulate some of these numbers. So it's a simple stock demo where, so you can see there, I've just changed the stock and the availability to 800. You can see that it's reflected in PG admin, that is connected to our RDS instance. And you can see that I've updated that, or what it looks like, right? So simple change. I don't need to get complexed into that. But what we're going to do is we're going to back up that stock change in a very operations-centric way. Like we've ticked round to the backup window, and we're now going to take that backup in a consistent fashion using Canister and Canister blueprints that dive in and talk to PG dump, the native backup system within Postgres, and then drags that data out and allows us to push that into S3, as well as being able to protect all the manifests and the application artifacts of the front-end web application as well. So simply put, we're going to run a snapshot, and then we're going to run an export out into our Amazon S3 location. What happens here if I refresh this, because we're leveraging the AWS APIs, you can see, if I refresh a few times, that status changes to backing up eventually. But what you will see is all these native AWS EBS snapshots that sit behind the RDS database as well. We're not reinventing the wheel. We're leveraging the AWS APIs to make this happen. Hopefully you just saw that status change to backing up. So the process is happening. We're obviously I'll speed this up because no one needs to sit here for 7 minutes while this is backing up. But ultimately what this is doing is throwing that data into object storage, into our S3 repository. Anything bad happens to our EKS cluster or our Kubernetes cluster, we've got the ability to restore that wherever we want as well. And Deepika's going to show what that means by we can restore it to any location later on as well. So you saw that. Hopefully you saw that. It went back to available. The export is just about finished. And then we're going to cause a failure scenario that means that we have to then restore our data within that. So here you go into the S3 bucket. This is just showing what that looks like with how we store the data within that S3 repository. And you can see all of our metadata and the data itself all reside in here. Okay, all good. We've taken that back up very quick. All good. Now, I think we should be showing the failure scenario. So once that does, it's just exporting the metadata to S3. And again, Deepika's going to show what that import process looks like into another EKS cluster later on with another demo. So how does it look from a restoring point of view? So obviously we've got a web front end and we've got our RDS database. So what we're going to do is we're going to use PG admin, or we're going to manipulate some of this availability stock levels. We're going to make some changes that cause us problems, so our salespeople can't go out and sell the fictitious stock that we have in there. So if I update that stock and just set everything out, just a simple SQL query to basically say update everything, I'm zeroing everything out and I'm manipulating it just to say, right, this is the line item, and I'm zeroing all of our availability out. Just a simple change that any administrator in the whole world can make from a DBA point of view. And accidents obviously do happen. So once that's done, obviously we've got that first restore point that we had, and I'm not going to make you all sit through us restoring that process, but what you'll see us do with the demo is we're going to remove the existing RDS database that is there, and we're going to restore a brand new RDS database from our backup from S3. So we go there, you see that our failure has been replicated into our web app, so now our sales people can't go and sell because we don't know what the availability of stock is. So we jump into K10, we head over, we see our restore points. The top one is a snapshot, an EBS snapshot, and the bottom one is our export out into S3. And again, I'm going to speed this up. But what we're going to see here is not only, and we can be granular about what this restore looks like. If we just want to restore the data, i.e. the RDS instance, we can do that. But if we want to restore everything, i.e. the front-end application as well, we can do that. For speed, I just hit everything. It's obviously not really a mission-critical application. But we can be granular on what we actually recover. Also bearing in mind that when we're looking at Kubernetes and microservices, we're probably going to have a bit more than just a front-end application and a back-end database. It's going to be a little bit more complex and microservice-esque from an application point of view. So we might have to pick and choose what data service we're going to bring back and how we're going to bring that back. So if we go and look at what that looks like inside of the Kubernetes cluster, so we need our front end. This should take no time at all. It's a stateless application. So yeah, we're all back up and running there. But if I go to that page, it's not going to come up. You can see here in RDS, we're communicating via the AWS API. We're deleting that existing database that has the problem with all the zeroed out. And we can choose here as well whether we delete it or what we do at that point. Again, for the demo, I just want to clear it away and I want to bring back the last known good configuration or last known good copy of data. And eventually you'll see that we're going to be creating a new RDS, and then we're going to push that Postgres database from PG dump ultimately, that consistent copy of that data back into our application, and then we're going to go and make sure that that data is where it needs to be. So now it's available. Obviously, I need to reconnect to everything, so jump back into it. Okay, we're back to where we were before. 135 stock availability left. Our sellers could go and use that to go and sell. And if we go and jump back into PG admin, reconnect again, but we'll be able to see that all of our data is back up and running, and we can start selling some products again. So the second demo is and one that I don't think I mentioned, but it would have come up on the slide that I was saying about this is everything that we're going to demonstrate, is the ability for us to leverage the object lock API within AWS S3. So what Deepika showed was us using it as a location profile without that API enabled. What we're going to do here is we're actually going to go through that scenario of, okay, what happens if someone bad gets in, whether it be an external threat or someone internal, and they go and try and delete that S3 bucket, but then equally they go and encrypt our database with a simple command that I'm going to share with everyone so you can start your own ransomware as a service business if you so wish. I mentioned around Kubernetes not being immune to ransomware, i.e. like people are already targeting and people are already trying to use Kubernetes or infiltrate Kubernetes for whether that be to mine Bitcoin or crypto, but equally that contains our mission critical data. We still have to protect it like we protect any other platform out there, whether it's an EC2 or virtual machine, VMware on AWS, etc. So what we do from a Kasten K10 point of view, and this is just the way in which we store the data, but if we think about our Kubernetes cluster, where all our applications are running, whether everything lives in there or there's an external data service, we then use Kasten K10 as the orchestration engine to move that data, a copy of that data, to object storage, i.e. we can leverage that, what Deepika showed, and just throw everything into an object storage bucket. Going one step further, we have the ability to protect that against ransomware or just even accidental deletion, right? People make mistakes all the time. So being able to leverage this means that we can get out of jail pretty quickly, and even AWS can't delete these buckets for the retention period of your data. Biggest point that hopefully everyone can leave with today: if you don't encrypt your data, regardless of where it is, someone else is probably going to, and it will cost you a hell of a lot of money if you haven't got a way of being able to restore that data. So yeah, from a demo point of view, let's simulate a MySQL database. I've not got a front-end application. I didn't have time to build anything. But if we look at our application, again, we have our location profile, and you see that we have two location profiles. We have one immutable, which you can see on there has some protection periods and some retention caveats on there. And then you have our normal S3 bucket that Deepika showed as well. We also then have a policy that is sending that My Production app into our immutable backup location. You can see that we've got a couple of restore points, so snapshot, both EBS snapshots and S3 exports. But let's get to the fun bit and start causing some havoc. So if we want to check the data, let's just check a simple MySQL query, gives us name and balance of our database. Again, just jumping into MySQL Workbench, we can see the same outcome, the same data within our database. Okay, so there's two attacks that we want to perform. One is against the bucket, i.e. I want to delete the bucket as an attacker, and then I want to encrypt the database, because that way I can't get that, or as a malicious actor, I know that they can't get that data back. So a simple script that I won't show and share what that's doing, but ultimately what this is doing is just calling AWS CLI and deleting the object storage bucket. So if we go in here and we go and have a look at our object storage bucket and we refresh things, you'll see that it's gone. Uh-oh, no backups, nothing's safe anymore. You also notice though that I don't have that versions, maybe you didn't, but there's a versions radio button, a tab that you can hit, and if you hit that, you're going to then see our K10 backups. Okay, so now I'm going to encrypt the database. Okay, that doesn't look as nice as it did before. Refresh that in MySQL Workbench. You see the idea here. So now we call upon our operations team who need to restore our data pretty quick because people want to get their balance and they want to be able to transact with my little banking application. So when it comes to recovery, this is where we can be granular about what we want to recover. They're all ticked by default, but you can go through and click what you need. So basically what I'm doing here is I'm restoring my MySQL database or MySQL deployment within our Kubernetes cluster. Again, I think I'm pretty much speeding this up. But you get the idea is that, so we're bringing up a restore pod that then instructs the Kubernetes, Kasten K10 then instructs the restore process to kick off. If I go show versions now, you still see that we do have everything under the hood, and we can't physically go in there and delete that. As much as it looked like we did as we refreshed and it was gone, the data is still very much there. It's protected by that object lock API. So once that restore has happened, you saw everything. You saw the crazy, I want to say wingdings type encryption on the data. So we should just wait for that MySQL store to come up. And then I'll just prove that the data's back and up and running again. And then we're good to go on to the final demo. And I appreciate that we've gone through quite a lot. We've showed you quite a lot in a short amount of time. But we wanted it to be a little bit different. We're on day 3 now, right? You've probably seen a lot of slides. So we wanted to jam-pack as much demo into it as we possibly could. And hopefully that's useful to see. So let's go and check that data again. And hopefully after the restore, everything should be back up and as it should be. Okay, good stuff. So everything's back as it should be. We can then access that through MySQL Workbench and see everything that we saw before. We'll have to reconnect our MySQL, and then there we go, everything's back up. Do I do anything else? No. Okay, so the final one that Deepak is going to touch on is around transformation. So I mentioned around being able to go from one cluster to another and providing that ability to change things as it's in flight or in that restore process. So I think we're on time. So do you want to just go straight into the demo?
Yeah, I'm going to go straight to the demo, just looking at the time. Kasten has a really powerful way of doing transformations. So we talked about having different EKS clusters. You might have one in your US West 2 or whatever. You might have one in a completely different place. Now you might have different storage classes on each side. Now what happens when you take a backup and you restore it in another place where the storage class is not available? You'd probably restore it, go and change everything up so that it gets up and running. So for that, Kasten allows you a Kasten transformation tool, which can do not just storage class change, but basically any YAML changes that you might want to do. So, change number of replica sets, or change your image repository, change the image name tag, whatever you want, you can do that. So to demo that, here I have a cluster in EKS2 where I have a MySQL application. It's running, and it is in GP2. So it's using GP2 storage class. So I'm going to go to the Kasten UI, and I think I already have the application backed up. And I'm going to do an export of the application. So I'm exporting one of the restore points that I have. And I'm exporting it to, again, an S3 bucket. Don't need a mutable, just a normal bucket. And once I export it, it's going to give me a migration key. So the migration key is going to tell me which export to look for, what bucket to look for, all that sort of information. So I can take that information and go to my target cluster, give it that information, and then it's ready to import from that same bucket, and it's ready to import this specific application. So we can look at the export happening right now. It's going to keep running for a while. But you can see that it's backing up whatever was backed up in the restore point. It's trying to push that out to S3. Now this is my target cluster in a different mode to show that there are two separate clusters. I'm going to set up an import policy, basically telling this cluster, import this information and then also do a restore after import. You can also do just an import only and then restore at a later time. This is adding the transformation that I just mentioned. So, we're changing the storage class from GP2. You could easily change anything else. We're changing storage class for VBCs. You could change whatever you want here in the YAML. It's pretty customizable. So we change the storage class. We're going to say, import daily if you can. And then we're going to paste that information that we got from the source cluster. So it auto-populated the field for the bucket because it knew that information from the target string that it had. So let's wait for this export to get done. There's a canister artifact, which is our open source project. So, it did all the processing it needed to do for this snapshot, and it's pushing it out to the S3 bucket that we have here, the demo bucket. Yeah, it's going to take maybe a second more to finish the export, and then we can go over to our target cluster and initiate the import. So when we go to our target cluster, what it's going to do is it's going to contact this S3 bucket that we set as the target. It's going to fetch the information. So it's going to fetch the latest snapshot that it finds there for this application. It's going to bring it down into its catalog, so in the secondary or the target cluster's catalog. So it's ready for future use. Now we said we want to import plus restore, so it's going to go ahead and restore it immediately. But you can only do an import only, so get all your snapshots into your target, and then you can restore it at a later time if you want to. For this demo, we are doing an import plus restore. So import is complete. It got that canister artifact. It got all the other metadata that it needs, and then now that this is ready, it's going to apply that transformation that we said, where it's going to change the storage class for any PVCs that might be in this snapshot, and then it's going to start the restore. So the import is done. It's waiting for the restore to kick in. So restore is starting. If you see, the target namespace is MySQL, so it's going to restore in this new namespace that it's creating. If we go back to the secondary cluster now, so I'm going to change my context and look at the secondary cluster. As you can see, one of the clusters is in US East 1, the other one is in US West 2. So completely disconnected clusters, but with the common S3 bucket for them to communicate with each other. So changing the context here so that we're in the new cluster. The restore is almost done. You can see that it's restoring everything, not just the snapshot, but all the metadata that comes with it. And it should be done, I believe. Yep, the restore is done. So we can go back to the cluster and look for our PVC, and hopefully it has the new storage class. Yep, cool. It's right there. So it's a new storage class. So this is just one way you can use Cadence transformations. And yeah, please check us out.
Yeah, awesome. Thanks very much. Yeah, we've got a booth. By all means, come and have a chat with us about some of this stuff.
All right,
thank you.
Thank you.